Today's topic is 3D visualization using SketchUp. We experienced SketchUp before, entitled SketchUp Modeling Without Experiences. But now we're going to learn surface-based 3D modeling using software named SketchUp. So what we need to do, what we need to know before making something using SketchUp is something about surface-based 3D modeling, okay? Before doing that, let's get talked about some schedule. We are in 9th week. Actually, we're gonna deal with SketchUp, not 3D Max or something else. And next week is kind of official holiday. Next after next week, we also gonna deal with SketchUp 3D modeling. Before, precision drawing using AutoCAD, okay? After that, we're gonna probably 2 or 3 weeks Autodesk lab exercises and some assignments for your drafting precision drawings by using AutoCAD. But before doing that, we're gonna deal with 3D surface-based modeling first today, okay? Next step to next week, I'm gonna tell you some detailed announcement about final project and your progress in terms of your lab exercises you have done and midterm exam, okay, as we scheduled in May 27th. What to do today, here listed up. Lab exercise 1, SketchUp user interface, no submission required, but lab exercise 2, 3, and 4 require those submissions. So you can refer to this page for today's submissions, okay? We're gonna talk this one in detail when we are dealing with some lab exercise issues. Okay. Last week, we have experienced some 2D vector graphics using PowerPoint drawing, 2D raster image editing using your digital pictures on top of Photoshop, okay? They are all 2D, but now we are moving on to 3D. So why we need 3D? So what is this? Actually, you may already checked out the course material, but anyway, this front view is kind of very typical 2D representation of a furniture, so-called plan views, front view, it's elevation. How about this top view? Top view represents the kind of top projection view of this object. And left view, okay, now we're gonna find out how it looks like. Right view, bottom view. Anyway, all these are just 2D representation of this real 3D object. But actually, how about this? Wireframe view, wireframe-based representation of this 3D object. This is hidden line removal and perspective view. If you are using AutoCAD or SketchUp, you can rotate this object and rotating upside down, zooming in and out, so that you can recognize this one is a certain type of furniture, chair. But design actually is not that complicated because all 90-degree, perpendicular, orthogonal shape design. No curves, right? But anyway, even if its design is not that complicated or it's not that hard to understand, hard to figure out, anyway, this kind of 2D representation has its own limitation. It's not easy to figure out the shape. But of course, there is a good thing. We can precisely measure the length, the depth, the thickness, and so on, because this kind of orthogonal view, 2D plan views, top view, front view, right view, those views are really easy to understand the object thickness, width, height, and so on. But it's still 2D. It's not hard to figure out object shape in real world 3D object. That is why we are using this kind of perspective view, hidden line removal, even sometimes photorealistic rendering, as you experienced before using V-Ray on SketchUp. So now you're going to move your perspective from 2D drafting to 3D modeling, top view, front view, elevation, even this kind of axonometric drawing or isometric drawing, they are still in 2D, just 2D based representation, not 3D object based. But after building your own 3D model, such as 3D surface model or solid model, it's something beyond 2D drafting. That's what we have learned before. So now we're going to deal with 3D modeling. One important thing is when you are using 3D surface model or solid model, this kind of top view, front view, even axonometric view, they are all just kind of subset of this 3D representation. If your camera is on top of this object and change your view, that's going to be this top view, okay? Just change, turn off perspective view, that's it. And then you can make this kind of view. What if you place your camera at front? Front view, even elevation view, left to right view, they can be easily derived from this 3D object, right? So making 2D drafting images, just one part of 3D model. Capturing some visualizations from the model. One type of rendering is this kind of drafting. Drawings, extracting drawings is one type of rendering. If you map this using some specific texture and colors, some reflection and object, and make some photorealistic rendering, that's another type of visualizations, rendering, right? What if you want to draw some line drawing based drawing without any colors, just shaded line drawings? That kind of visual effect is also one type of rendering from 3D model. It couldn't be generated from 2D based model, okay? Totally different. So let's review a brief CAD history again. When we believe 2D drafting is a design itself, 2D drafting is enough for representing specific design, specific object, even building design, mostly using floor plan. But surface-based 3D model mechanism and technique invented by some engineers, scientists, and now we use this kind of 3D surface-based model. This notation means this is a subset of this 3D model. So 2D drafting is a subset of 3D surface-based model. And then we developed some solid-based model. We're going to talk about the difference between solid and surface-based model today. But anyway, surface-based model revolved into some solid-based model. And parametric modeling is a kind of advanced type of solid model, which has parameters, editable. We can control its height with steps so that geometry going to be updated by editing those parameters. The most advanced thing is building information modeling. It contains everything. Parametric modeling, solid modeling, even surface-based model or 2D-based drafting is just one tiny subset of information. The term information in building information model, okay? But we are dealing with this part. 3D surface-based model, especially using SketchUp, and 2D drafting, mostly using AutoCAD. But I told you, we're gonna deal with SketchUp first, and then AutoCAD, okay? That is why today's topic is SketchUp, surface-based 3D model. Let me show you again this classification, very simple classification. SketchUp, AutoCAD, 3D Max. Probably you may use one of those software for your design visualization in your design studio, at least until second or third year grade students. But in third year, in digital design class, you may learn Autodesk Revit, Autodesk Vasari, and some additional BIM software. They are all in this category: solid model, parametric model, and building information modeling classification. But anyway, now we are in this area, surface-based 3D. And also, I'm gonna tell you how to generate 2D drafting using 3D model before dealing with AutoCAD or 3D Max. Let's talk about surface-based model. What is a surface-based model? Surface modeling is really handy and efficient and, simply say, good to visualize any type of 3D objects, okay? Not only the real world object, but also some certain kind of virtual objects, such as game characters, game objects, or houses, certain kind of built environment. In game environment, they are all surface-based model. Whatever you are playing games, the 3D objects in your game environment, they all defined by this kind of surface-based model, okay? Actually, this example from Wikipedia shows you how to make certain type of surface using vertices. These vertices, so-called control vertices, you can manipulate the location of vertices, and some spline or some knobs. Sometimes Bezier curve-based algorithm will be applied for making that kind of non-uniform organic shape of surface, okay? But actually, especially for architects, interior architects, we are dealing with real-world object. You are not game designer. Whatever you design, interior architecture or building in exterior, whatever, they are all something real object. Sometimes it's gonna be erected, constructed, manufactured, okay? We are not cyber designer or game designer. We are dealing with real world object. So surface-based model is really handy and good to visualize something for your design, visualization and representation, but eventually this is not the perfect and only one solution for building design, okay? That is why we need some type of solid model, solid 3D model. Let me show you some brief definition, very simplified definition. A solid model is an unambiguous computer representation of a physical solid object. What's the meaning of unambiguous? Let's take a look at this one, non-solid 3D model examples. Take a look at this one. Actually, this is 3D object, but there are 3 planes. Plane means certain type of 2D elements which has 0 thickness. This is mathematical, okay? No thickness. In surface-based model, this is fine, no problem. But in real world objects, there is no such element, no such thing. even this kind of paper, okay, let's take a look at this paper. It looks like a surface, but anyway, this one has its own thickness. Even if it's 0.1 millimeter, anyway, this one has thickness. But the plane in computer, mathematically defined planes have any thickness, okay? That kind of difference you should take care of. This one, this plane, doesn't have any thickness, zero thickness, which means that this is mathematically defined, logically defined by computer and visualized. That's it. There is no way to realize this one in real world, okay? How about point? It's mathematical, it's conceptual, nothing real. Even line, curves, they are all mathematically defined or computer defined that kind of elements. But in real world, there is no such points, lines, surfaces, okay? How about this? This one looks like real. That looks fine. But take a look at this dangled object. This dangled surface shows this one is not 3D solid model. In solid model, there is no this kind of object. How about this? The string, this is parametric modeler. The biggest part in its radius, but radius going to be shrinking down until it's going to be 0. So that is why this connection shows a kind of curved line, but this line couldn't be exist. It's not possible in real world. So this is just surface-based 3D representation, not real object. Klein's bottle is a good example of non-solid 3D model. This is surface-based model. You may know this one, Möbius string. This one doesn't have any inside or outside. This is kind of 3D version of this Möbius string, some different version of Möbius string. Klein's bottle follow the surface area. There is no inside, there is no outside, okay? Simply follow by the surface. We cannot differentiate which one is inside and outside. So avoiding this kind of ambiguity is the reason for using solid model. Okay, some more examples. Why we need solid modeling? Simply say, avoiding invalid and ambiguous 3D representations. Take a look at this one. This is a fake. You know that. This is a fake, nothing real, so-called devil's fork. It's invalid one, okay? This kind of line drawing sometimes makes some illusions and some invalid, but looks okay. So that's going to be a problem in 3D modeling. How about this? As I introduced you before, this one looks like that kind of solid object, a box shape which has an empty hole. But actually, some more representations can be exactly same to that one. This is so-called ambiguous representation of 3D object. For figuring out the issue, some definition and mathematically well-defined object compared to ill-defined object, something like those things, something invalid, something ambiguous thing, we have to resolve this problem so that you can get into well-defined 3D model, okay? That is why I brought up this idea, geometry versus topology. You may know what is geometry. So what is topology in Korean? 위상기하학. Okay? let's take a look at the difference between geometry versus topology. What information is necessary to represent this simple shape, this rectangle shape, as a computer model, computer calculable model? Okay, very simple. You may learn this one in middle school ages, I think. Firstly, we need this kind of Cartesian coordinate system in 2D, x-axis and y-axis. And take a look at points, 4 points definition. 2 by 1, 3 by 2, 2 by 3, 1 by 2. Very simple, x, y coordinate system. So 4 points definition and make lines to connect each other like this way. And some define next phase as a surface. This connected 4 lines gonna make this kind of one surface. Simply fill the color so that we can recognize that's a surface. Anyway, mathematical, this is kind of a definition of mathematical way, exactly same to computers, okay? Also, computer screen knows x-axis and y-axis coordinate points where it should be located, 4 points and their connections, and they're gonna be enclosed and make one surface. That's very explicit, straightforward definition of computer to make that shape. Okay, this is geometry, okay? This is geometry. How about topology? How to define topology? Actually, topology defines relations, not coordinate system, okay? How to define topology? Let's take a look at V0 through V3. The term V here means vertex, okay? Vertices 0 through 3, they're gonna be connected like this way. So last one, connected like this way. So vertices 4 edges, E0 through E3 means edges. And combination of 4 edges gonna make one face, okay? That is why I use the term V, E, F. So this is relationship between 4 different elements, vertices, edges. So let's compare topology and geometry, different geometric shapes with the same topology. Okay. Line drawing gonna get started from vertex 0, and next move on vertex 1, 2, 3, and 0 again, so that this one gonna be enclosed. How about this? Same relationship, same topology, but because of different location, coordinate system, they look totally different, right? But topology is the same, okay? But different geometry. Okay, how about this? Those 2 images show you P0 through point 3, they have exact same location in its Cartesian coordinate system, x, y, 2D plane, right? Exactly same position, but the problem is different connection. Different relationship, P0 through P1, but P0 to P2 and others. That is why 4 points has the exact same geometric coordinate location, but because of different topological relationship, they are looking totally different, okay? Diamond shape and some kind of cross shape. Same geometry, but totally different topology. Okay, to define a specific geometry, which one is important? Correct answer is simply both, okay? you need topology and geometry. Okay? I show you why. I show you two examples. Same topology, but different geometry made this problem. They are looking totally different. Also, this one, same geometry, same geometric points, location, but totally different shape because the topological connections are different. That's the problem. So, simply say, we need both, okay? Especially computer needs both geometry and topology for correct representation of geometric shape. Geometry is in charge of defining values of locations of points. Topology defines relations between points, between vertices, okay? Let's take a look at some simple comparison between those two things in terms of its terminology. Under geometry, point. 2 points gonna make one single line. Some enclosed lines gonna make surface and space. Under topology, vertex. 2 vertices gonna make one single edge, and enclosed edges gonna make face and shell. For geometry, let's draw this kind of XY plane. Points, 4 points in specific location, lines, surface. They are the term for geometry. How about topology? 4 vertices, okay, V0 through V3. Their relations, V0 through V0, enclosed. And the final one is face. That is the term under topology. Defining a closed surface for making a valid 3D object. We talked about some validity about 3D model, 3D geometry. Okay, let's take a look at this one. V0, V1, V2, V3, again V0, which means this is enclosed, okay? Closed loop, closed topological definition gonna make this kind of closed 2D shape. How about this one? V2 through V1, it's not closed. Also, this one is not closed, even if some closed part is here. Simply because we need this kind of closed roof. If we extrude this one in Z direction for making 3D object, this is kind of valid 3D object. But actually this is another 3D representation, just surfaces. No solid 3D object gonna be created. The same as this one too, right? We need a closed 2D representation for making solid 3D model, valid model. Or even this one can be a surface model. Using SketchUp, you can make this one without any problem. But anyway, it looks valid, no ambiguity, because it's going to be representing certain type of real-world object. But that one, it's non-solid 3D model, so-called surface-based 3D model. It is really good to visualize anything, such as virtual objects, of course, including this kind of real-world object. But that is why this kind of surface model is mostly used for visualization. So SketchUp is in this definition, okay? Surface-based model, not solid-based model. SketchUp is a non-solid 3D model, surface-based model, okay? So let's take a look at some 3D graphics software interface again. Here I list up some famous and commonly used software for interior architects. SketchUp, 3D Max. Actually, in this semester, we're gonna deal with SketchUp and AutoCAD, not 3D Max. Next year, probably second semester of second year, you're gonna learn 3D Max using several additional software. This one looks very complicated. This is 3D Max interface or GUI. We actually studied this revolving interfaces before, but let me show you this one again. CLI, GUI, NUI. General software we use today, probably you may use NUI frequently than GUI-based Windows, because your smartphones, your tablets, that is very commonly and frequently used software interface today. But actually, what you have to learn for 3D modeling, 3D visualization as an interior architect, they are all within this area. Mostly GUI, but some of command line we need, such as AutoCAD command line interface or some SketchUp command line interface. We're gonna learn today for that kind of command line based interface in SketchUp. Anyway, this kind of gap, ideal way, gonna be NUI and some part of GUI, 3D laser scanning, image processing, something beyond keyboard and mouse. That kind of interface is sort of ideal way of making 3D object. Making 3D model using 3D interface, that's simply ideal way. But in reality, most 3D graphics tools, including SketchUp, Rhino, Maya, 3D Max, we are all handling 3D objects on top of your 2D screen, 2D monitors. Using GUI, very messy and hard to learn. Very complicated 3D modeling on 2D views. Too many icons, limited interface because of the limitation of GUI. Too many options, functions. It's not easy to figure out what to do. So this gap simply makes you hard to learn 3D software. That is why you are feeling kind of uncomfortable and some experienced difficulties when you are dealing with SketchUp. Even though SketchUp is really, really easy tool for making 3D object anyway. But here are a list of actual reasons why 3D graphics software is too hard to learn. Here I ask a simple quiz. Do you know these terms? Ray tracing, global illumination, bump mapping, bone shading, Bezier curve, UV mapping, sweeping, lathing. Something about camera and the lenses. Last week we have learned something about lenses. Now you know what is focal distance and the numbers, 20 millimeter, 100 millimeter in lens. I think now you know what it means, okay? But anyway, without understanding these terms, without understanding what is mesh, what is sweeping, what is camera lens and focal distance, without those things, learning 3D Max or SketchUp or even any other type of 3D geometric modeling tools, it is equivalent to memorizing the order of clicking buttons among hundreds of icons in really messy GUI interface. If you understand the logic, rather than memorizing the order of sequence of clicking icons, clicking buttons, can learn any kind of complicated 3D software, because if you understand behind the technologies, some theoretical backgrounds and something intrinsic aspect of 3D modelers and visualization tools. Just one thing left: user interface. Different icon, different buttons, different menu system. What you need to know is just simply try to use it. You may find out where is Bezier curve, where is freeform deformation, where is rendering button, something like that. So simply say fishing rather than fishes. Okay, if you learn 3D Studio Max very intensively and just assume that you are an expert of 3D Max, so what? That's it. If newer version of 3D Max released, you have to learn again and again. Kind of iterative process, very tedious. But if you understand fundamental mechanism of 3D geometric modelers and renderers and so on, just GUI, user interface-ish, left behind you. That means you can learn just user interface. Where is that button? What you deeply understand what it is. That means you can learn anything. Blenders, Maya, digital project, even Revit or some complicated BIM software, you can learn without any problem. That's my point here, okay? Let's take a look at some basics about SketchUp. Actually, Google sold SketchUp to Trimble software, Trimble buildings. So nowadays, SketchUp is not Google SketchUp any longer, actually. So this is kind of new logo of SketchUp, but formerly, Google SketchUp logo was over there. Okay, let's take a look at main characteristics of SketchUp and its model. I told you it's surface-based 3D modeler. SketchUp model is always surface-based model, not solid 3D, which means that, excerpt from SketchUp for Dummies book. Anyway, this image shows you what is surface-based model. When you cut this one, you may find out hollow inside, empty inside the hole. But if it's a solid model, even if you slice out, cut it out, always subdivided elements are kind of solid. So even if it looks like a 3D box, anyway, the subcomponents are here, edges, and their combination makes series of faces, okay? If you delete this face, the inside gonna be hollow, nothing, because they are all surface-based 3D model. This is very simple case. How about this kind of single house model? It looks very complicated, but anyway, it's still kind of collection of amount of faces composed of edges, okay? So edges in geometric term, lines and faces, so-called surfaces, gonna make surface-based 3D model. That means you can control edges, you can control faces. If you push-pull this face, this cube size is gonna be shrinking down or getting bigger. If you control this edge, if you rotate this edge, box shape gonna be dramatically changed. We're gonna take a look at this one in lab exercise hours. Okay, how about curve lines? This one looks like a curve using this kind of two different arcs. But actually, if you're zooming in, you may find out they are still collection of straight lines, okay? Actually, they are just a collection of straight lines. Even this kind of organic shape, wheels, or some similar objects, they are all combination of flat and straight lines. So take a look at this organic form, organic shape surface. In detail, they are all triangular shapes, surface. They are all flat, okay? One by one, flat triangular panels are all in totally flat planes, okay? Any organic shaped surfaces are still a collection of flat surfaces simply because this is surface-based model, okay? Of course, you can control the number of surfaces. If you make this surface using just 10 surfaces, just 10 triangular shapes, this shape gonna be looking very coarse. But if you apply 1,000 flat triangle shapes, this one gonna be really fine-grained. That means very realistic organic shape. But even if you applied 1,000 triangular shape, if you zooming in 100 times, and then you can find out there are still flat surfaces, okay? That's real and some salient aspect, characteristics of surface-based model. We're gonna deal with this one today's lab exercise. Okay, some more things, especially using SketchUp tips for interior architects and some more issues. We're gonna deal with this one just after break. So please wake up and keep focusing on today's lab exercise issues and some technical things, okay? There is dimension, and you can simply click one of the lines like this, another line here, okay? Okay, how about circle? How about circle? Click this one, circle, and draw somewhere here, like this. And you may find out at this time, when you draw circle, the term here is radius. Radius around 4,000 millimeter. Simply type 4m. So this one gonna be exactly 4,000 circle. Click tools, dimensions again, and simply click this one. So you may find out this is exactly 8,000 millimeter, okay? Because I used radius 4 meter, so that's eventually 4 meter. Okay, this is perspective view. What if you wanna see this one precisely, even more precisely? Click camera and click standard views and click top view. Okay, this is top view, but actually there is a problem. Still, z-axis is visible. That means this is perspective. So let's make it parallel projection. Click camera and click this one, parallel projection, not perspective. Currently it's perspective. If you click parallel projection, okay, there is no z-axis because it's exactly orthogonal. So z-axis is moved out. This is totally 2D representation, okay? So you can, even if you zooming in and out, this one is okay. If you rotate the view, this is still parallel projection. Okay, get back to top view and click standard view and change the view to front view, okay? Okay, this is front view. The woman is standing around this X and Z axis, and some lines are visible. They are some objects we just created, okay? So this is exactly orthogonal projection view or front view. And you can change this bottom view, right view, left view, even iso view, and so on. This is isometric view, okay? So this kind of precisely generated views enable you to draw something very precisely. For architects, for interior architects, we can take advantages of typing numbers, and there are some more things. I'm going to show you examples, demonstration in lab exercise hours, okay? A lot more things remained. Actually, some more tips for precision drawing. We can use some vertices, edges, and faces for geometric modeling, moving it, rotating it, scaling it, and so on. We're going to deal with this part too in lab exercise hours. We can make our component named components so that you can reuse them. Also, there are several different view styles, view types, animation view, and several different scenes. Also, we can take a look at this area too. There are some salient aspect of SketchUp when you are doing something architectural, interior architectural designing, modeling, visualizing, and so on. Let's take a look at some rendering preview. Actually, we already experienced V-Ray-based rendering before, so let me quickly review this one again. Using V-Ray plugin, you can visualize, you can render anything, especially for photorealistic rendering, thanks to the power of V-Ray. V-Ray shows very natural and photorealistic rendering outputs. You can refer to those references, amount of tutorial videos in internet, YouTube. So here are some examples we already actually reviewed before. Your SketchUp already installed the V-Ray plugin. And next thing I would like to introduce you is 3D Warehouse. You can simply type 3D Warehouse in Google or connect 3dwarehouse.sketchup.com. And then you can find out this one, predefined models. But this is kind of old version, and recently, now you can find out this kind of interface, website. If you type single house in search window in SketchUp 3D Warehouse, you may find out amount of SketchUp models under the search string single house. More than 1,000 single house model. You can simply download it, but you don't need to use web browsers always. You can simply access this website using SketchUp interface. We're going to deal with that. And the component, such as plant, furniture, designer chair, Herman Miller chair, Herman Miller table, desk unit, anything else you can search and download, directly integrate into your SketchUp interface. So this is one part of today's lab exercise 4, okay? We're going to deal with SketchUp interface and how to use components, some additional geometric modeling features, some precision drawing, some useful tips for SketchUp in lab exercise hours, okay? Handling this kind of complicated icons and interfaces.